Math, I've heard many times that they say math is the universal language. And I think when we say that, because, the operation of math, 2 plus 2 equals 4, that doesn't change whether you are in China, whether you're in Taiwan, whether you're in the Philippines, whether you're in America, that's going to stay the same. But what's very interesting is that we all do use such different words to describe what we're doing in math. So, we'll just go ahead and get started. Like for those who have been in some of the other classes, these last two classes with me, definitely chime in and ask any questions that you may have. You can just interrupt me. Luke kind of knows to just kind of wait, and I'll pause a couple of times throughout just to give people an opportunity if you have any questions. So I will go ahead and begin sharing my screen, and we'll get started. Okay, so let me just present here. Okay, so English for mathematics. That is our topic today. And so today's lesson, what I'd like to review is first going over numbers and their English expressions. We all know that we call numbers different things in different languages, but even some of the expression like saying 2 to the fourth power, that's something that is very different in different languages. Next, mathematical symbols, just to learn what those are called in English. Then we'll do a quick review of geometric shapes and some terms that go along with geometry, trigonometry, those types of things, more advanced mathematics. And then we'll learn language of simple mathematic expressions. So this is going to really be, I think, the heart of what this lesson will cover, just because it will show us how, if you are teaching a math problem or if you have an expression that you'd like to say, it'll give you ways to be able to say that. And last but not least, this was not in the original presentation that was sent out earlier today or last night. But it's just one extra slide that I wanted to go over about order of operations. I think most people here, most of the observers have probably heard the popular phrase that we have in English to remember our order of operations. And I just thought that would be a great way to wrap things up. So let's get started. So numbers and their English expressions. So here on the left side of the graph, we have a bunch of different expressions. So I want to start with we'll just kind of read through them and you'll be able to see what those are in English. So 32% is how we would say that. The next one, 10 meters by 3 meters. So in English expressions, whenever there is an X that is between two numbers in an expression like that, especially elevated, that means by. So this would be if you were speaking of, like, let's say the dimensions of a room, and you wanted to say the room was 10 meters by 3 meters. This is how you could express it in mathematics, and how you would say that in English. The next one is 8.3. So whenever we have a decimal in English, we use the word point as to distinguish the period or to distinguish the decimal. So you could say 8.3, 8.325, but the point is what we use to describe that signal that goes into the hundredths, the tenths, hundredths of an expression. Next, we'll go into some fractions. So in expressing fractions, we would use 1 and 2/3. So you always say the whole number and then you add the fraction. So 1 and 2/3. Secondly, we have 3/4. So that's just a regular fraction, 3/4. Next, we'll talk about exponents. So exponents are expressed in a few different ways. So if we have an exponent of 2 or an exponent of 3, those are sort of the outliers here. So when we have an exponent of 2, we say squared. So that would be 3 squared, which would be 9. In the second example here, we have 2 cubed. So whenever something is to the power of 3, which is what we would say when there's an exponent, that it's to the power of 3, we call that cubed. So this is 2 cubed. Okay. And next, any number that has an exponent over 2 or 3, we would say to the power of 4. So 2 to the power of 4. The so that's kind of from there on you would say that. So 2 to the power of 5, 2 to the power of 6, and so on and so on. Only 3 squared, the exponent of 2, which the little number above here, that's called an exponent. An exponent. So any exponent that's 2, we would say it's squared. And if you're getting into higher math, like maybe algebra, you're looking at algebraic expressions, you could say a squared, b squared, x squared. Same thing here, 2 cubed, 3 cubed, x cubed is how you would say that. Next, moving on to numbers, I think for the most part, if you have if you have some English background, you probably can express numbers pretty well. So 1975, that would be like a year, 2001, or you could just say 2001. That is the more common way, I would say. You could say 2001, but most commonly, most people would not say that. They would say 2001 without the and. Next here, we have it, which appears to be like a phone number. So 263-3847. Below we have degrees, so 26 degrees. And you can denote the C for Celsius or an F for Fahrenheit, depending on what temperature you're using. Next, just a big number broken down. So I won't spend too much time there. And lastly, the last line of this here, just how we talk about our cardinal numbers. So 21st, 92nd, 53rd, and then 67th. So on the right side here, I just want to go over a few clues and a few helpful hints. So in English, only first, second, and third are different. So if you notice below, when we say 21st, 92nd, 53rd, we're using the ST, ND, and RD suffixes on that phrase. Whereas with 67th, we're using the TH. Now, all numbers after first, second, and third, all other numbers are going to have a TH. So whether you're talking about 6th, 7th, 9th, 10th, 11th, to infinity, unless you have numbers 1, 2, 3, so like 51st or 72nd or maybe 103rd. Only first, second, and third are different. All other numbers are going to be with a TH. And I think we already expressed this a little bit, but most commonly, if you have something like 2 to the fourth power, that's how it's going to be said. 2 to the fourth power. I know here in our diagram it says 2 to the power of 4, which is also correct. That is not an incorrect way to say that, but just most commonly expressed in English, you would say 2 to the fourth power. And lastly, this phone number, or at least it looks like a phone number, You could definitely say this phone number with each individual digit, 263 3847. But many people, and it is very common in English to combine these last four digits into and to combine those last four digits. So you would say something like 263 3847. So, and that's just a matter of preference. Some people will say it that way. Some people will give each individual digit. The I think there's a little bit, and I can't quote a psychology study on this, but I think definitely with grouping the numbers like 3847, it helps people memorize a number a little bit better because it's only two numbers to memorize versus four different ones. So, either way, it's all on preference there. But I'll stop here momentarily. Does anyone have any questions about this chart or what we've gone over so far?
Okay, I have a question for you. When it comes to ratio, for example, the TV screen ratio is 16 by 9. Can we use by?
16 by 9? So
Yeah,
let me just
ratio.
express this like a ratio. So if you were saying 16 by 9 like this, can you see me or do I need to stop sharing my screen?
I can see you. I can see you.
Okay. So this would be like a 16 by 9, or do you mean a ratio let's see, like 5 of 10?
By, when you are trying to make some slides, the PowerPoint or keynotes will ask you what ratio you want to choose, right?
Oh, yes, yes. So you might say you want it to be 360 by 120. That's correct. Yes. So
Okay.
that is correct.
Yeah, the most popular options are 4 by 3 or 16 by 9, right?
Yep, 16 by 9. So yes, both of those that you are exactly right. That is how you would express it. If you wrote it out, you could do the time symbol, so it would be 4 by 3, or you could just, or 16 by 9. But yes, exactly. Uh-huh.
Okay, thank you.
Yes, you're very welcome. And please, keep any of those questions coming. I do have my little handy dandy whiteboard here, so we can do some problems if we need to for some more examples. So please definitely ask any questions that you may have. Okay, so from here, I'd like to move on to mathematical symbols. And this will just kind of go through what we call different symbols and how we express them when we are using them in a phrase. So on the left side here, we will start with some of the more minor ones, less advanced. So we have plus, minus, multiplied by, divided by, plus or minus, if you have the plus and the dash. And then we have greater than or less than. And of course, for us, and in English, we always read it from left to right. So let's say, for instance, you were saying 96 is greater than 40. We always would read it left to right. So you would use the greater than symbol to point to whatever the greater number is. And that's how we would read it. 96 is greater than 40. Or if you were going vice versa, you could say 2 is less than 10. And you would read it left to right, less than 10. Okay. So next up, down our middle column here, we of course has equal to. And I saw someone say, excuse me, did anyone have a question really quick that I could answer? in the chat? I did see a chat pop up, excuse me. Anyone need any help with that? Okay. If not, I will keep on moving. But please feel free. Excuse me, how do I say temperature? -3 degrees Celsius. So that's how you can say that. 3 degrees Celsius. That's And I see some exceptions. Exception 11th, 12th, 13th. Those are true. Those are exceptions to the 1, 2, 3 rule. Very good to point that out. Thank you, Daryl, for pointing that out to the RD rule because it wouldn't be that. So very good exception there. So here we go. We'll continue on. Thank you, observers, for chiming in. I appreciate that very much. Okay, so next we have is not equal to, similar to, is congruent to, the infinity symbol, infinity, is greater than or equals, and then less than or equals. Next, and these are some more advanced ones that we would use in more advanced mathematics, trig and possibly a little bit of calculus, pre-calculus, but equivalent to implies theta, an empty set, a triangle, or in a mathematic expression, we would use that as delta or a change in. Would it be another way to say that? For all, and then of course pi, the representation of pi. There. Any other questions on the mathematical symbols? All right. So let's go on to some geometric shapes and terms for those. All right. So I hope everyone can see this. It's a little bit small, but I think it's coming through. But here, this is definitely on the geometric side. So we have a straight line, and then we have perpendicular lines. And of course, with the perpendicular lines, they're the ones that form the 90-degree angle. So this little box that we have in our perpendicular lines, this is called a 90-degree angle. And so that's what makes our perpendicular line having this 90-degree angle is what we would call that in English. All right. Um, we have a curve, an arc, a circle, radius, and diameter. So those are, the radius from the center to the circumference of the circle, and then the diameter reaches the full amount. Then there is a section. So that's about a quarter of a circle in that section. We've got square, rectangle, and then the diameter or diagonal of a rectangle is there too. And if we took that rectangle and we made the triangle, took the triangle out, we could then see that we have the side of the triangle, the apex of the triangle, and the hypotenuse. So the hypotenuse is the diagonal piece of a right triangle there. And there's, of course, if you go a little bit further into mathematics, there's some theorems and things that are all about the hypotenuse and solving for the lengths of the sides of the triangle. But we won't go into that for this lesson, but that is called the hypotenuse. Next, we have an oval. The center of the circle, which is where we are going to measure our radius from, the center to the circumference. Whole, half, quarter, as I mentioned before, a cube, cylinder, pyramid, And then below here, we just have some descriptions in order to find the area and of an object. So we have here a a rectangular cube here, and you can see that we have our designations of height, width, and then the depth. And then using those are what we would solve for the area and for each of those sides. So depth, width, and height. And then we have our cone and parallel lines. So we've learned three different types of lines that we have: a regular straight line, our perpendicular lines, and then our parallel lines. The three different types of lines that we have here. All right, I will stop here for any questions, comments, concerns here. All right. Very good, everyone. So let's then go on to our language of simple mathematical expressions with sample problems. Okay, so this is just an overview of what we're going to go through over the next few minutes. And we have our basic math operations, which we will call addition, subtraction, multiplication, and division. And so I won't spend a whole lot of time on this particular slide because we are going to get to look at each one of these a little more in depthly. So I'm sorry that it's a little blurry here, but addition will be our first one. So addition, there's different ways that we say addition in a mathematical expression. You could say increase, together, and more, plus, which is the very common one, 2 plus 2, um, add, total, sum, and when we say, I wanted to distinguish that when we say sum and total are a little bit different because those two are typically not represented just by the plus sign or just by the addition symbol, but the sum is what you get once you add everything together. So, for instance, let's look at number one. What is the sum of 55 and 40? So, sum is a word for what are those two numbers added together. And so you see there 55 plus 40 equals 95. So that would be how we would say that statement there. 55 plus 40 equals 95. You could also say 55 and 40 equals 95. You could say 55 together with 40 equals 95. But I would say in most if you're in most math classes, and what is most commonly said is that it would be 55 plus 40 equals 95. So the second problem here that we have, what is the total of 100, 30, and 60? So again, using that word total is a way to ask you to add these numbers together. So again, we have 100 plus 30 plus 60 equals 190. And lastly, 25 and 75 is how much. Sometimes that will also be asked because the and is telling us that we are looking at and we are figuring out both of those numbers together is how much. So again, you could do 25 plus 75 equals 100. Do we have any questions here on this first element of simple operations? Okay, let's continue. So we'll go to its opposite cousin here, subtraction. So subtraction is the one where we're taking things away. We're reducing something. And so some of the words that we use when we are speaking of a subtraction phrase would be the difference between. That's a very common one. The difference is another word for subtraction or minus. Of course, we can use subtract. You can use reduce, fewer, minus, take away, take from, decrease. These are all words that can be used in different types of expression for a subtraction problem. So let's look at some examples. What is the difference between 65 and 30? So in English, when we're teaching subtraction, difference is one of the main words that they drill into us as students. Whenever you see a problem that's asking for the difference, it means that it's a subtraction problem. So what is the difference between 65 and 30? That would just be 65 minus 30 equals 35. Another way we could say this, subtract 950 from 1,000. So you would start with the 1,000 minus 950 equals 50. Another way, you begin with 20 apples and take away 7. How many are left? So this is another sort of word problem if you're getting into word problem work with your students. This could be a way that you could phrase it. So take away is another way to say subtract. So here, 20 minus 7 equals 13. And lastly here, what is 15 fewer than 45? 45 minus 15 equals 30. So definitely with subtraction, I feel like there are more common ways that we reference subtraction in mathematics and English. And I use just a few of those examples here. How does everyone feel about that? Does anyone know of any different ways, or are you used to one or the other?
All I can all I can say is minors. Like
Minus.
5 minus 30 equals 35. So we have never seen these sentences. The difference between subtract and take away fewer than. So yeah, these are something
Yes.
new.
Yes,
Here.
these are very, and you know the minus is definitely like the one that is used. I mean that's either minus or subtract. Either for subtract 60 from 100 or 65 minus 30. So that's definitely the most common, but difference is used especially this is more, I think, used in academia. If you were on the street or if you were talking to a family member, you would not usually say, "What is the difference between 65 and 30?" You would just say, "What is 65 minus 30?" And so I think some of these are definitely more academic in use when you're actually in a math class discussing these terms. But you definitely, especially take away and fewer than, those are a little more common. But I think if you know minus and subtract, you're definitely on the right track. These are just some extra terms that we use commonly in math classes.
Got it. Thank you.
Yes. All right. So we'll go back to presenting here. Next, we'll move on to multiplication. So multiplication has several, which that word I know, even for me, saying multiplication, that's kind of a little bit of a hard one, even for a native English speaker, for myself at least. But multiplication, we can say several things. Multiplied by, multiply, groups of, lots of times, times tables, product. Now, of these, I have listed here the most common ones. Some of these are not used very often, but I wanted to just kind of provide them. But if we look at the examples on the right side, we can see the ones that are most commonly used. So 20 multiplied by 10 is, so we could do 20 times 10 equals 200. If you want to use a parenthetical expression, you could also do that, equals 200. Um, and the other thing is times. The bottom one here, I don't think I put times on here, but a lot of people would say 20 times 10. So 20 multiplied by 10, 20 times 10. We as elementary students, we learn our times tables. We memorize those as elementary students. So times is definitely a very popular one too. Number two here, what is the product of 12 and 8? Which is just 12 times 8 equals 96. So product is definitely one of those words similar to difference that we saw here. Difference. Product is another word that when you're taking math classes and when you're in academia, product is a word that is used often when speaking of multiplication problems. So what is the product of 12 and 8? 12 times 8 equals 96. And then, of course, multiply 6 and 20, and you would get the 1200 there. Um, so that is, oh, and I guess just since I said it, 1200. I don't think I discussed this on the previous slide, but one other tip for expressing things in English, if it is a smaller number in the thousands, such as this, many times we won't say 1,200. We'll just say 1,200. Or let's say the number was 6,300. A lot of times we would just say 6,300. So that is just another common way in English that we would say numbers that end in that are just a zero zero are 1,000, but could be any number: 6,400, 7,200. You don't always have to say 7,200. You can just say 7,200. All right. Any questions on multiplication? Okay. Division. All right, so division, some of the words we use: divided by, share, divisible by, share equally, divide, divide into, and group. So these are just some phrases that we can use when talking about division. And I used the slash for my division symbol because I couldn't figure out where to find that on my keyboard. I know there's a special key that you can hit to get that symbol, but we know the slash is also divide. So number one here, we see 20 divided by 10 is, so we have 20 divided by 10 is 2. Um, what is 500 divisible by 20? 500 divided by 20 equals 25. And then we can also say divide 20 into 480. So that would be 480 divided by 20 equals 24. Now, The one thing I want to bring up when using division that can be a little bit confusing when we say it in English is that if you notice in number one and number two, the number that is being divided by another number is said first in the expression. So we're doing 20 divided by 10. In the second example, 500 divisible by 20. But if you notice in the last example, we're saying divide 20 into 480. So it's actually the way we're saying it is reverse of how you would actually do the problem. So you would actually take 480 divided by 20 to get your 24. So that is just something to keep in mind if you ever use the phrase divide something into another number. When you're actually computing that, you would start with the number that you're going into and take out and divide by the number that is smaller there. Um, for regular, I guess you could also get a negative number there as well. So, any questions about division and any words that we use for division? Ah, quotient. Yes, I did see an observer brought up the word quotient, which is also another term that we use in division. So that is a good call out too. Thank you for that quotient. Very good. And the last slide that I wanted to bring up, and this is the one that I added, and I can send out the new PDF just as a resource for everyone, but it's concerning the order of operations. So as we move into a little bit more advanced math, especially in different algebraic expressions, this is something that I'm sure most observers who have been in math class or taken an algebra class or anything of that nature have probably heard this phrase. But in English, there's a very popular phrase for the order that you do a math problem that contains parentheses and exponents. And we call the phrase, please excuse my dear Aunt Sally. And what that basically stands for is that you want to start with your parentheses, move into your exponents, then do multiplication division, followed by addition and subtraction. And you want to do each order of operation, of course, from left to right. So this is just a cute little phrase that I know many math teachers have taught over the years just to keep students in mind of the order that they should work a math problem. And you have an example down here of a math problem that contains parentheses and exponents. And so it kind of shows you which ones you would want to do first and to come up with the answer here of 126. But I couldn't leave out an English mathematics lesson without the famous "Please excuse my dear Aunt Sally." I think that's something that has stuck with me since I was probably in fifth or sixth grade. So just thought I would throw that in there as well. Um, so that will be the end of the presentation. I want to open the floor up for any questions or feedback or yeah, just kind of open floor for everyone.